Hello students, in the last two lectures we see some examples on the basic definitions of the matrices. Okay, now in this lecture we see some another examples on the definitions of the matrices, that is the types of the matrices in the exercise 4.4. okay, now we see the remaining 4 examples in the exercise 4.4. okay, here it is example number 7. Find A, B and C if the matrix it is a 1 3 by 5 A, B minus 5 minus 7 minus 4 C 0 is a symmetric matrix. Okay, now here see carefully. Here it is a given matrix. Okay, suppose it is a let A. The matrix A, it is 1 3 by 5 A, B minus 5 minus 7, and it is a minus 4 C and 0. Okay, here it is a given matrix, and given that A is a symmetric matrix. Okay, here see carefully. A is a symmetric matrix. What is the definition of the symmetric matrix? If see carefully, it is A is a matrix. Here it is a Aij. Okay, then all elements in the matrix it is a Aij. Therefore Aij is equal to Aji. Okay, all the elements with position Aij is equal to Aji. That means it is a row number and column number. Here we replace row number and column number. That means if, okay, for example, A13 is equal to A31. Okay, that is A is equal to, it's a transpose. A is equal to A dash. A dash, it is a transpose. Matrix is equal to its transpose. That means it is a it is a symmetric matrix. Matrix is equal to its transpose. It is a symmetric matrix. Okay, or we can find by using this Aij is equal to Aji. Here we want to find the value of A. The position of this A, it is first row third column. The first row third column is equal to third row first column. That means it is a 4. Okay, now any concept use here, the elements or the transpose. Okay, matrix is equal to its transpose. The given matrix A is a symmetric. Therefore A is equal to A transpose. Okay, therefore we can find the transpose. A transpose, row becomes columns. It is 1 3 by 5 A first row, then B minus 5 minus 7, then minus 4 C, and it is a 0. And we know that A is equal to A transpose. Okay, that means the corresponding elements are the same corresponding elements. Here it is the first row first column, first row first column. First row second column, it is a first row second column. First row third column, it is a first row third column. Therefore we can directly write it is A is equal to A dash. These two matrices are the equal. Okay, here we can write in a one line. Okay, or compare this. A and A dash are equal. Therefore the corresponding elements are the equal. Therefore 1 is equal to 1. Here it is. Then 3 by 2 is equal to B. Therefore we can write B is equal to 3 by 2. Then A is equal to minus 4 and C is equal to minus 7. See carefully. We can write in the sequence A is equal to minus 4, B is equal to 3 by 2 and C is equal to minus 7 are the values of A, B and C if this matrix is a symmetric matrix. Okay, symmetric matrix, it is a matrix is equal to its transpose. Aij is equal to Aji. Okay, here in the symmetric matrix, here it is minus 5, it is 4. The position of the 4, it is a 3 1. Okay, that is a third row first column. Third row first column element is equal to the first row third column. Then it is a first row third column. Therefore A is equal to 4, B is equal to 3 by 5 and C is equal to minus 7. We can write directly also. Okay, here we use the step by step. If A is a symmetric matrix, then matrix A is equal to its transpose. So these two matrices are equal. Then compare the coefficients. Compare the corresponding elements. 1 1, it is 3 by 2 B, that means B is equal to 3 by 2 or this B is equal to 3 by 2. A is equal to minus 4 or this minus 4 is equal to A. It is the value of A, B and C. Okay, now we see the next example. Same example, but it is here. Find x, y and z. X, y and z if 0, minus 5y and x, y, 0, z. It is a 3 by 2 minus under root 2 and 0 is a skew symmetric matrix. Is skew symmetric matrix. Now here the given matrix 0, 5y, x, y, 0, z. It is a 3 by 2 minus under root 2 and 0. Now given A is a skew symmetric matrix. Okay, write carefully. A is skew symmetric matrix. Therefore A is equal to minus A dash. It is a definition of the skew symmetric matrix. Here A is a matrix, then Aij is equal to, for the symmetric skew symmetric matrix, it is Aij is equal to minus Aji. That means if the 1 3 position element it is a 5, it is 1 3. Okay, and therefore 3 1 position element it is a minus 5. Okay, A13, that is first row third column. If first row third column element is 5, then the third row first column element it is a minus 5. So here x, it is a first row third column and it is third row first column, it is a 3 by 2, therefore it is minus 3 by 2. See carefully the definition. Here it is a third row first column, it is 3 by 2, therefore it is first row third column, it is a minus 3 by 2. Here it is a 5i, first row second column, therefore second row first column, it is first row second column and it is second row first column, it is minus 5i, therefore it is minus 5i. And here it is a second row third column, it is a z, and third row second column, it is a minus root 2, therefore z is equal to minus root 2. Okay, we can directly write by using this concept. Okay, or A is equal to minus A dash, it is a skew symmetric matrix. A is equal to minus A dash. So first we find the A dash, therefore it is A dash, that means transpose. Okay, transpose it is 0, 5y, x, y, 0, z, and then it is 3 by 2 minus root 2 and it is a 0. Okay, see carefully. Now we find the minus A dash. Okay, here Again erase it. Therefore it is minus A dash is equal to, we multiply all element in A dash by minus. Okay, in the matrix if we multiply some number, so multiply the all element in the matrices. Okay, here there are the 9 element, minus A dash, therefore minus 0, it is a minus 0, minus y and minus 3 by 2, minus 5I, minus 0 and it is root 2, minus x, minus z, it is a 0. Okay, and now minus A dash is equal to A, this A. Now compare these two matrices. Okay, here first row first column is equal to first row first column, then first row second column is equal to this. Okay, now A is equal to minus A dash, and therefore we can write minus y is equal to 5I, minus y is equal to 5y, then minus 3 by 2 is equal to x, minus 3 by 2 is equal to x, and now we find the value of z. Therefore here root 2 and it is a z, therefore root 2 is equal to z, and therefore we can write this x is equal to 3 by 2, sorry, it is minus 3 by 2, y is equal to minus 5I, and z is equal to under root 2, it is the value of x, y and z if it is a skew symmetric matrix, symmetric matrix and skew symmetric matrix. Okay, here definition concept clear kara, it is A is equal to A dash, it is a symmetric. Okay, and skew symmetric, it is A is equal to minus A dash. Okay, here हा concept व्यवस्थित लक्षात राहू द्या. Matrix is equal to its transpose, it is a symmetric, and matrix is equal to minus of its transpose, it is a skew symmetric. And position नुसार काय, elements Aij is equal to Aji is equal to, it is a symmetric, and Aij is equal to minus Aji, it is a skew symmetric matrix. Okay, now we see next example. Next, example number 9. For each of the following matrices, using its transpose, state whether it is a symmetric, a skew symmetric, or neither. Okay, here the first example. 1, 2, minus 5, 2, minus 3, 4, minus 5, 4, 9. Second, 2, 5, 1, minus 5, 4, 6, minus 1, minus 6, 3. And third, 0, 1 plus 2i, it is I minus 2, minus 1 minus 2i, 0 minus 7, 2 minus I, 7, 0. Okay, here, these are the three matrices. We have to check which of is a symmetric, skew symmetric, or the neither. Okay, here symmetric and skew symmetric. Symmetric matrix means a matrix is equal to its transpose. Okay, and skew symmetric, it is a matrix is equal to minus of its transpose. Okay, now consider the first. Let A here 1, 2, 5. Sorry, it is minus 5. 2, minus 3, 4, and then minus 5, 4, and it is a 9. Okay, here it is a matrix A. We want to find its transpose. Okay, therefore A dash is equal to, see carefully here, 1, 2, minus 5. It is a transpose. That means row becomes column and column becomes row. 2, minus 3, 4, minus 5, 4, and it is a 9. Okay, from these two, it is A is equal to A transpose. See carefully. 1, 1, 2, 2, minus 5, 2, 2, minus 3, 4, 4, minus 5, 4, 4, and it is a 9, 9. That means two matrices are the equal. A is equal to its transpose, and therefore A is a symmetric matrix. A is a symmetric matrix. Now we consider the second. Let you can take A or some another name. It is a say B. 2, 5, 1, minus 5, 4, 6, minus 1, minus 6, 3. Okay, see carefully. Now we find the B dash. See carefully. B dash, that means the transpose of matrix B. Therefore it is a 2, 5, 1, minus 5, 4, 6, minus 5, 4, 6, and it is 1, sorry, it is minus 1, minus 6, 3. Okay, it is a transpose. See carefully. 2, 5, 1, it is a 2, 5, 1, minus 5, 4, 6, minus 5, 4, 6, and minus 1, minus 6, 3, minus 1, minus 6, minus 3. It is a transpose. And now we observe here 2 is equal to 2, but here minus 5, and here it is a 5. Okay, here it is a 5, here it is a minus 5. Therefore B is not equal to B dash. B is not equal to B dash. Okay, here now we find minus B dash. Okay, we know that here if matrix is equal to its transpose, then it is a symmetric. Okay, and matrix is equal to minus of its transpose, then it is a skew symmetric. Now here B is not equal to B dash, that means it is not a symmetric matrix. Now we check it is a skew symmetric or not. Minus, so multiply each element by minus. Therefore it is a minus 2, 5, 1, minus 5, minus 4, 6, minus 1, minus 6, and it is a minus 3. See carefully. Now you observe B, this matrix B, and it is a minus of B dash, minus 2, sorry, it is a 2 and it is a minus 2. The first row, first element is not equal. Okay, here corresponding all elements are the same, then the matrices are the same. If any one is not equal to that the corresponding element, then the matrices are the not equal. Here it is a 2 and it is a minus 2. Therefore, B is not equal to minus B dash. That is, B is neither symmetric nor skew symmetric. It is neither symmetric nor skew symmetric. That means that neither. It is a not symmetric or not a skew symmetric matrix. It is a symmetric matrix. Now, we see the last example, that is this. Here, the third example. Suppose it is a C. See carefully. 0, 1 plus 2i. It is I minus 2. Minus 1 minus 2i. It is a 0 minus 7. Then it is a 2 minus I. 7 and it is a 0. Okay. Now, first we find the transpose. Therefore, C dash. See carefully. Row becomes column. Therefore, it is a 0, 1 plus 2i. And it is I minus 2. Okay. Now, then it is minus 1 minus 2i. 0 and it is a minus 7. And last, third row becomes third column. 2 minus I. 7 and it is a 0. Okay. Here. Now, these two matrices, 0 equal to 0, but here minus 1 minus 2i. Here it is a not minus 1 minus I. So, these two matrices are the not equal. That means it is not a symmetric matrix. Okay. Therefore, okay, we can write here C is not equal to C dash. Okay. Now, we find minus of C dash. See carefully. Minus of C dash. We multiply by minus. Here it is a 0. We multiply this minus. Therefore, it is a 1 plus 2i. When we multiply minus, it is plus, it is plus. When we multiply, it is minus. Therefore, it is minus 2 plus I. That means I minus 2. When we multiply here minus, it is a minus 1 minus 2i. When we multiply here, it is a 0. When we multiply minus, it is a minus. We multiply all element by minus this. Okay. Now here, again, minus plus, that means 2 minus I. It is a plus 7 and it is a 0 as it is. And now here, C is equal to minus C dash. C is equal to this minus C dash, and therefore it is, that is, C is skew symmetric. Skew symmetric matrix. Okay. First matrix, it is a symmetric. Second matrix, here it is neither, that is a neither symmetric nor skew symmetric. And the third matrix, it is a skew symmetric matrix. Now we see the last example in this exercise. is example number 10. Construct the matrix A equal to Aij, whose order it is a 3 by 3, where Aij, the element Aij is equal to I minus j. State whether matrix A is symmetric or skew symmetric. Okay. Now, first we construct the matrix A. Okay. Here it is given matrix A is here Aij, it is order, it is a 3 by 3. That means, see carefully here, that is the matrix A is A11, A12, A13, 3 rows and 3 columns. It is a first row, first column, first row, second column, and it is first row, third column. Now it is a second row, first column, second row, second column, and it is second row, third column. Then third row, first column, third row, second column, and it is a third row, third column. Okay, it is our matrix. Okay, given matrix. But for finding the each element, there is a condition: Aij is equal to I minus j. Okay, here also given Aij is equal to, it is I minus j. See carefully. Now the first element A11, it is 1 minus 1, that means 0. It is the first element. A12, it is 1 minus 2, it is a minus 1. And A13, it is a 1 minus 3, that is minus 2. These are the 3 elements. A11, 0. A12, it is minus 1, and A13, it is minus 2. Now A21, it is a 2 minus 1, that is 1. A22, it is a row number minus column number. The elements are Aij is equal to I minus j. It is I minus j, I minus j, and it is I minus j. Now it is I minus j, and then it is a 0. A23, it is a 2 minus 3, and that is minus 1. And then last row A31, 3 minus 1, it is a 2. A32, it is a 3 minus 2, and it is 1. And A33, it is a 3 minus 3, it is a 0. Are all elements. Now therefore matrix A is, see carefully, A11, it is a 0. A12, minus 1, 0, it is minus 1 and minus 2. Then 1, 0, and here minus 1. 1, 0, and that is the minus 1. Now here it is a 2, 1, and it is a 0. Okay, here it is our matrix A. The first question is complete. Construct the matrix A. We construct this matrix, and now we check this matrix is a symmetric or the skew symmetric. Okay, and here we clearly observe that here it is minus 1 and it is 1. That means Aij is equal to minus Aji. Aij 1 1, it is a 0. A21, it is 1. Therefore A12, it is a minus 1. Here clearly here Aij is equal to minus Aji, and therefore A is a symmetric matrix, skew symmetric matrix. A is a skew symmetric matrix. Okay, here you can find by using this, or it is a A, then we find A transpose, and then we find the minus of A transpose, and then A is equal to minus A dash. It is a skew symmetric matrix. Okay, see carefully, it is a complete our exercise 4.4. okay, see carefully all examples.